Hey guys, and welcome to this lesson video about our first exponent properties. And one note, for this lesson video in particular, I really would like you to be diligent about writing down all of the notes that appear in the lesson video. You could certainly get by with writing very little, but I think in terms of having a really good conceptual understanding, please write down pretty much everything I do. So with that, let's do it. So the first example I want to talk about is, well, what happens when we take 5 to the second power and we multiply it by 5 to the third power? 5 to the second, 25, 5 to the third, 125, I don't know, you get a big number. But one thing I want to note here is that we have two exponential expressions and each have the same base of 5. And what I claim is that we can write this product as actually 5 raised to, well, some power. What power? I don't know. Let's find out. Well, note to self, 5 to the second, that just means 5 times 5, right? Multiply 5 by itself 2 times. And then we're multiplying that by 5 to the third, which means, well, 5 times 5 times 5, right? Multiply 5 by itself 3 times. And what do we end up with? Well, what I think we have here is 5 being multiplied by itself, coincidentally, 5 times. So I think our product in this case can be written as 5 to the fifth power. Totally coincidental that our base and our exponent happen to be the same. But this is kind of the property that we're going to hone in on right now. What happens when we have two exponential expressions, the same base being first multiplied by one another or perhaps divided by one another? So let's do another example and see what happens. So here we have a base of -6, so -6 to the third power, multiplied by -6 to the fifth power. Well, I think we know what -6 to the third power is. That's just -6 times -6 times -6. And to be quite frank, anytime you ever see some base being raised to a positive power, please try to visualize exactly this. Sometimes students hyper-focus on just the kind of symbolic numbers, and they lose focus of what it means to take a base and raise it to a power. So envision this, please, if you will. I think it'll make your life a lot easier. And well, -6 raised to the fifth power, well, we know what that is. That's -6 times -6 times -6 times -6 times -6. And you know what I think we end up with? I think what we've got on our hands right now is -6 being multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8 times. So I think our product in this case is -6 raised to the 8th power. I mean, hopefully that's not too surprising. I mean, we've got 3 -6's being multiplied by one another here. We've got 5 more being multiplied by one another here for a total of 8 of them. All right, so in this case, in our third example, hey, we're dealing with a variable, but nothing new. Perhaps you can predict that our product in this case will be w to the 6th power. Why? Well, because w squared means w times w, and w to the 4th means w times w times w times w. No surprise that we end up with 6 w's being multiplied by one another, hence w to the 6th power. So that's kind of our first property of exponents that I want to explore. Now note, everything is all groovy when all we're dealing with is positive exponents, right? It's very easy to visualize, and you take care of it, no problem. My question here is, well, what happens if we have negative exponents? So I want to take a moment to discuss 2 more examples with negative exponents. And perhaps you're noticing some patterns here, and feel free to utilize them, but we want to make sure we know what's going on behind the scenes. So let's use our knowledge of the definition of positive and negative exponents. So 7 to the 5th power, I know means 7 times 7 times 7 times 7 times 7. Now 7 to the negative 3rd power, I'm going to write this as 1/7 times 1/7 times 1/7. So maybe you already had a prediction about what our product was going to be, right? 7 raised to some power. But let's take a moment to talk about what happens when we multiply these together. Well, note that 7 and 1/7 are reciprocals of one another. They're multiplicative inverses. They multiply together to give 1. So I'm going to do this. I don't like to use the C word, but cancel them out. They multiply to 1, so we don't need them anymore. This pair of 7 and 1/7 multiply to 1. This pair of 7 and 1/7 multiply to 1. I think we are left with 2 7's being multiplied by one another, 7 to the 2nd power. Now perhaps you predicted this earlier, just looking at our original expression. Perhaps always good to know what's going on behind the scenes. All right, we continue. Now we've got our 5th example in which we have both exponents are negative. What does that mean? I don't know. Do we have an anticipation, a guess as to what our product might be? 9 raised to some mystery power? Let's find out. So in this case, let's see, 9 to the negative 2nd, I'm going to write that as 1/9 multiplied by 1/9. Using our definition, we know what negative exponents are. 9 to the negative 5th, 1/9 times itself 5 times, 2 times, 3 times, 4 times, 5 times. All right, I think what we have on our hands here is I think we've got 1, 2, 3, 4, 5, 6, 7 1/9 being multiplied by one another. I'm actually going to write this as 1 over 9 to the 7th power. And to be quite frank, if we were going to deliver something to our reader, I think this is a really, really good product. Right? All we have are nice positive exponents. But I think it's good to note that this expression right here, 1 over 9 to the 7th, is exactly the same as 9 to the negative 7th power. So perhaps you anticipated this beforehand, but if it's between 9 to the negative 7th power and 1 over 9 to the 7th, I think an expression with positive exponents always is going to trump one with negative exponents. Definitely easier for our reader to read and understand. We certainly could have written these originally. We could have just written this as 1 over 9 to the 2nd, and we could have written this expression as 1 over 9 to the 5th, and then perhaps from here it becomes clear exactly what's going to happen, right? 9 times 9 times 9 times 9 times 9 times 9 times 9, we're going to end up with 1 over 9 to the 7th. So our first property of exponents down. Once again, perhaps you're noticing some patterns that allows you to do these quickly and easily, but it's really good to know what's going on behind the scenes. Now note, one thing to be aware of is that this property that we've been talking about works only if our bases are the same. If our bases are not the same, for instance, 2 to the 3rd power multiplied by 5 to the 4th power, nothing special we can do with that. I mean, I don't know what it is, but I'll tell you, it is not equal to 10 to the 7th power. So note that all of these examples that we dealt with in our first 5, all of the bases were the same, right? 5 and 5, negative 6 and negative 6, W and W, 9 and 9, etc., etc. So really important, those bases have to be the same. Now what happens when you do some division? Well, here's our first example. We got a lot of nice positive exponents. When I see positive exponents, I like to do some visualization of, for instance, in this case, 2 being multiplied by itself a whole bunch of times in both our numerator and denominator. I think it makes life really easy, right? I think 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is also 1. Hey, we end up with 2 times 2, also known as 2 coincidentally to the 2nd power. All right, not so bad. Maybe you're going to notice some patterns again. All right, let's check out our second example. Once again, all nice positive exponents. 5 to the 7th, well, 5 times 5, 3, 4, 5, 6, 7. Woo! 5 to the 4th power, 1, 2, 3, 4. I think clearly 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 is 1. We end up with 1, 2, 3 5s being left multiplied by one another, 5 to the 3rd power. All right, I'm feeling good. Again, when you have positive exponents, life is groovy. It's very easy to visualize, very easy to simplify, and find your final answer. Same thing here. Maybe you give this a try before I walk through it, but let's see. W to the 4th, W times W times W times W over W to the 9th. Yowza, maybe I can use this to my advantage. 4 W's being multiplied. 8 W's being multiplied. And there's your 9th. All right, so once again, boom, 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 boom. 4 pairs of W's in our numerator and denominator will simplify to 1. We end up with 1 over W to the 5th power. Life is good. Remember, always a good idea to give your reader a final answer where all exponents are positive. Don't want to give your reader a negative exponent. That's not very nice. Okay, so just like before, our first 3 examples have used only positive exponents. Very easy to visualize. What happens if we have negative exponents? Let's take a look. Okay, like I mentioned before, it is so important that we are comfortable using our fraction skills to simplify expressions like these. You may find some patterns and they're helpful to finish these problems quickly and accurately, but really want you to know what's going on behind the scenes, and that requires fraction skills. So let's take a look at what we've got. Our numerator, we're going to leave as just 4 to the 2nd for a moment. Bear with me. So what I want to do is, my first objective is rewrite this expression as one where we have only positive exponents. Okay, that's our first goal. So 4 to the 2nd has a positive exponent. Let's leave that as is. Our denominator, 4 to the negative 3rd power. I hope we know that that is the same as 1 over 4 to the 3rd power. So now what we've got here is one of those kind of awkward fractions, if you will. I don't like those awkward fractions. So what I'm going to do is I'm going to write this numerator, 4 to the 2nd. I'm going to write it as 4 to the 2nd over 1. Okay, so now we've got a fraction over a fraction, which I'm going to write. Now, I know we rarely ever use this notation, but check this out. I'm going to do it just because it might help. We have this fraction divided by this fraction. Oh, and I hope that when I take this complex fraction right here and I write it as just a division problem, okay, hopefully from here we're home free. we know how to divide fractions. We are instead going to multiply this by the reciprocal of 1 over 4 to the third, also known as 4 to the third over 1. Now, using our fraction properties from before, exponent properties from before, I think we know that our product in this case will be 4 to the 5th power. All right, so we were able to simplify this expression just using definition of a negative exponent and using our fraction skills. That's it. No big deal. All right, let's try another one. Holy cow. We've got a negative exponent in our numerator and a negative exponent in the denominator. Yowza. It's okay. First goal, let's write everything using only positive exponents. So our numerator, 6 to the negative 2nd power, that's the same as 1 over 6 to the 2nd. Our denominator, 6 to the negative 4th power, that's 1 over 6 to the 4th power. Now, I really would like us to be comfortable enough going right from here to knowing that, this is fraction division and how to handle that. But if you need, just to make it a little more clear, I will rewrite that complex fraction explicitly as a division problem. Note that these two expressions are exactly the same, and I really want us to be comfortable with that. And from here, hopefully it's smooth sailing. We're going to take 1 over 6 squared, and instead we're going to multiply it by 6 to the 4th over 1. We end up with 6 to the 4th over 6 to the 2nd. I hope we know how to handle that. All right, 6 to the 4th is 6 times 6 times 6 times 6. 6 to the 2nd is 6 times 6. We have two pairs of 6's that will simplify to 1. We end up with just 6 to the 2nd power. And as we do more and more of these, we'll get more comfortable and be able to kind of make our way through a little bit more quickly, maybe able to omit some of the steps. But it's really important, again, to be comfortable with our fraction skills to handle expressions like this one. So that was our second property of exponents that I wanted to talk about. What happens when you have two exponential expressions with the same base now being divided instead of multiplied? All right, time for some practice. Some of these look just like the ones we've been doing. Some of them look a little bit more difficult. I'm going to walk you through each of them, but why don't you give them a try now and then play the video, and we'll either see how it went or I can walk you through it. Okay, so for our first example, I'm thinking, all right, we've got division. Let's write everything with positive exponents. So I'm going to preemptively write our numerator as d to the 2nd over 1, and our denominator will be 1 over d to the 3rd. I know that this is actually a fraction division problem in disguise, and I know how to take care of fraction division problems. I'm going to take d to the 2nd over 1 and multiply it by the reciprocal of this guy, namely d to the 3rd over 1, for a grand total of d to the 5th power. Awesome. In our second example, once again, you know what? We've got negative exponents. I want to write these with positive exponents, please. And I'm going to preemptively, because I know I'm going to have some fraction division business, I'm going to write our denominator as 2 to the 3rd over 1. I just think it really helps for me so I don't have one of those awkward fractions, if you will. All right, well, we've got a fraction division problem going on here. And you know what? Instead of writing the division thing right here, I'm comfortable with my fractions. I know immediately I'm going to multiply by the reciprocal of our denominator, so 1 over 2 to the 3rd. If you need to write that interim step with the division sign, kind of like what I did right here, go for it. But eventually I'd like us to be just comfortable enough to get right to here. And I think we know that our product will be 1 over 2 to the 7th power. Awesome. Okay, phenomenal. Now in this third example, this is the first time we've ever had two different bases going on at once. But you know what? It's the same thing. I'll walk you through it. First things first, let's write everything using only positive exponents. So I'm going to write g to the negative 2nd power. It's interesting. If you would say this verbally, you'd probably just say g to the 2nd, g to the negative 2nd, k to the 3rd. But there's multiplication going on in here, right? There's no I don't write it in. We don't write those dots. Sometimes I do just to make it more clear to myself. But this is multiplication happening here. And it's really important that we know this is multiplication here. So g to the negative 2nd, I'm going to write as 1 over g to the 2nd multiplied by just k to the 3rd. Now, here's the thing. I'm going to have a fraction being multiplied by something. Let's make this k to the 3rd into a fraction, kind of preemptively knowing that it's going to help us later. So k to the 3rd over 1. Okay, that was our numerator. Woo! Our denominator, k to the negative 1st power, so that's 1 over k to the 1st, times, once again, I'm going to write g to the 5th as a fraction just to make our lives a little bit easier. All right, so holy cow, right? We've got fractions all over the place. Hey, but this is big boy and big girl math. We can handle this stuff. What I'm going to do now is we have positive exponents everywhere. That's great. What I'm going to do now is I'm going to write this numerator as just a single fraction. Right, I'm going to multiply those together. And I think we'll get, let's see, k to the 3rd over g to the 2nd. So our numerator becomes k to the third over g to the second. And our denominator becomes, let's see, g to the fifth over k to the first. So g to the fifth over k to the first. Now I'm hoping that when we get to this point, we've really done the bulk of the work. I mean, now this just looks like all the other problems we had, right? When we had fractions over fractions. I mean, these are the exact same type of problem here, and we know how to do it. I'm going to write in that extra step and write, so we've got our numerator. I'll even copy and paste it so that it's super clear. We've got our numerator here, and it's actually being divided by our denominator. And you know what? We definitely know how to do fraction multiplication, or excuse me, fraction division. So k to the third over g squared multiplied by k to the first over g to the fifth. I hope that this is absolutely no problem for us. We end up with k to the fourth power over g to the seventh power. So definitely a lot of work. Definitely a lot of fractions. And just using our knowledge of what positive and negative exponents mean, creating some fractions with positive exponents, creating more fractions, and just using our fraction skills. So actually, these exponent properties are really a lot of fraction skills. Okay, two more. I'm going to make my way through them a little bit more quickly. All right, so a very similar example going on right here. So I'm going to write our numerator as a to the third over 1 multiplied by, well, b to the negative second is 1 over b to the second. Our denominator, I'm going to write this as 1 over a to the seventh times just b to the first over 1. I'm going to kind of simplify and clean up our numerator and also our denominator. Our numerator I will write as just a to the third over b to the second, right? That's what we get when we actually multiply these two fractions together. Our denominator will be b to the first over a to the seventh, which is what we actually get when we multiply these two fractions together. Over a to the seventh, and right, feeling good, I know what's going on. We actually have this numerator being divided by this denominator. This is actually a fraction division problem in disguise. Okay, we know how to handle this. A to the third over b to the second multiplied by a to the seventh over b to the first for a grand total of a to the 10th power over b to the third power. Phenomenal, phenomenal, phenomenal. All right, last one. Here we go. Why don't you take a moment? Why don't you take a moment to pause the video, try this on your own, and when you're done, play the video, and we'll see how it went. All right, so now that we finished, all I did was I first used my knowledge of the definition of negative exponents, rewrote any base with a negative exponent as one with a positive one, and then I kind of cleaned up the numerator, cleaned up the denominator, recognized this as fraction division, rewrote this as fraction multiplication, took care of business using our properties. So that's it for this lesson. I hope you found it helpful, and I hope you enjoy.